Hello, my name is Kots Kanu and today we are going to discuss on rule-based DFM for drilling. So what exactly is drilling? Drilling is a cutting process used to cut or enlarge a hole of circular cross-section in solid materials. In this process, we uses a rotatory multi-point cutting tool which is pressed against the workpiece and forces the cutting edges to remove chips from the hole as it is drilled. What is DFM? DFM is designed for manufacturing and it is also called design for manufacturability. DFM allows us to design product to facilitate manufacturing process and help to precisely define various tolerances, rules and manufacturing checks in design phase, which allows potential problems to be fixed in design phase. Now we would discuss some rule-based guidelines for drilling. While designing hole for drilling, it should be taken care that entry surface is perpendicular to axis of hole because otherwise drill bit would slip on surface and may lead to damaged workpiece. As you can see in the left one that the shown surface is not perpendicular to the axis and in the right design the shown surface is perpendicular to the axis. Hence, the right design would be preferred over the left design. Through holes should be preferred over blind holes because they can be burred easily and would result into more precise and clean holes. Even if there is necessity for blind hole, then flat bottom hole should not be preferred because it would require an extra cost, labor and time due to conical shape of drill bit's tip which help it in progression to drill a hole. Hence, flat bottom hole should not be preferred and try to make hole conical at end. While designing hole, it should be taken care that hole is not intersecting with cavity because otherwise when we would try to drill such a hole, then drill would follow the least resistant path and would try to tilt and shift towards the cavity, which may result in breaking of tool and imperfect hole. So it should be tried that hole would not intersect any cavity asymmetrically when, and even if it cannot be done, then try to shift center of hole as far as possible from cavity. As we can see here in the right figure, they have redesigned their component and shifted the center of the hole away from the cavity. So the right design would be more preferable than the left design. Deep holes with small diameter should also be avoided because drills with small diameters are less stress resistive and hence tend to wander, which may lead to breakage of tool or an imperfect hole. Deeper hole would also create difficulties in taking out chips from the bottom of the hole, and it was found that hole diameter to depth ratio should be less than 3, or if it cannot be done, then other process should be preferred over drilling. Hence, this design would be preferred over this. As you can see in the figure that the red design should not be preferred as it is deeper than the green design. Partial holes should also be avoided and try to keep center of holes away from the edges as much as possible because otherwise due to uneven forces on drill bit would result in vibration, imperfect hole or even breakage of tool and may lead to ruin the workpiece. So it is advised to keep at least 75% whole area inside the material to prevent such kind of damages which may increase cost due to scrap, and hence green one should be preferred over to the red one in the shown design. Before designing it should be analyzed that what size of drill bits are available in workstation, because manufacturing or purchasing a new drill bit would add unnecessary cost to manufacturing. Accessibility of hole is also another parameter be counted during designing a hole. In this shown design, we can see that it would be difficult to drill the hole because obstruction would prevent drill press head to come close to the entrance surface. One solution that is possible is we can increase drill bit size to reach the entrance surface of the hole, but that would increase shattering, vibration and other instabilities during drilling because of increase in torque and other forces. So we can either redesign our components so that hole cannot be drilled without hole can be drilled without any obstruction as shown in the left figure, or design part into two parts so that hole can be drilled before assembling the part that was creating obstruction during drilling. As in the left figure we can see that we can manufacture the bottom part differently and the above part differently, and first drill hole in the bottom part and then assemble both the parts and we can get the required design. Other aspects are holes of size less than 1/8 inches in diameter should be avoided, because otherwise drill bits would with material that can withstand high stresses would be required, which would add another cost to manufacturing. Large holes should be tried to manufacture from casting and then bored out to achieve required specification, because drilling large holes would require more time, coolant and may result in change of material properties due to high rate of material removal during drilling, which would generate a lot of heat. Holes with different sizes should be avoided because tool changing time would be counted in manufacturing time, and similarly number of directions that is needed to drill holes should be minimized, because rotation and orienting tool would also increase manufacturing time. Accessibility of hole should also be keep in mind during design, and when there are multiple holes are there on workpiece, then it should be preferred that they would have equal distance from bottoms, because then we can use some fixture which could drill multiple holes at a single time.